Hey guys, Ms. Gosling here. In this video, you're going to learn about radioactivity and safety. By the end of the video, you'll be able to explain how and why you need to shield yourself from radiation. So let's go ahead and get started. I want to start by introducing you to 4 people who were early nuclear physicists and therefore had one of the most dangerous jobs out there. So we have Marie Curie, famous for her study of radium and also famous for being the first woman to win a Nobel Prize in physics and one of the only people to win a Nobel Prize in multiple categories. She has a Nobel Prize in physics and one in chemistry as well. She also died of radiation poisoning. Henri Becquerel, you may have heard of him. He's also a well-known nuclear physicist. Also died of radiation poisoning. And finally, we have Louis Slotin and Harry Daghlian, both folks involved in nuclear research in the U.S. With the Manhattan Project. Both of whom, again, died of radiation poisoning. So in this video, we're going to talk about what radiation poisoning is, why you should avoid it, and how you can avoid it. So with that, let's go ahead and get started. So we're going to start by talking about why we need to be careful of nuclear radiation. So nuclear radiation is known as ionizing radiation. And ionizing radiation can distort DNA, damage cells. It can also cause radiation poisoning, cancer, and radiation burns. In fact, most of you have had a radiation burn before. Because a good example of radiation burn actually is a sunburn. And you have heard, I'm sure, that you want to wear sunscreen in order to protect yourself from the sun, from that UV radiation, because being exposed to too much ultraviolet radiation can cause skin cancer. So this is one example of dangerous radiation. This is not exactly the same as what we see in nuclear reactions on Earth, but our alpha, beta, and gamma radiation has the same ionizing potential. Or has ionizing potential just like ultraviolet radiation. And so it can destroy your DNA, damage your cells, and in even more significant situations can cause radiation poisoning, cancer, and burns. So let's start. So radiation is bad, right? We don't want to get in the way of it. We do actually experience some radiation at all, in our backgrounds throughout our lives. There's kind of constant background radiation. That we can't really avoid. It's just happening naturally in the unstable isotopes that exist on Earth. That is not a dangerous level of radiation in most places, including here. But if we are right near a radioactive substance, here are a few things that you can do to protect yourself from that dangerous radiation. So with alpha particles, it's really easy. Just don't ingest them. So don't drink them, don't breathe them in, use them as eye drops. Alpha particles cannot get through your skin. So they are actually they have the most ionizing potential of any of our kinds of radiation. But they can't make it through your skin, and so unless you ingest alpha particles, you should be perfectly safe from them. This is one reason, if you've ever seen a radon detector in houses, that we have to be careful of radon. Radon is an unstable nucleus, and unlike most unstable nuclei, so unlike something like uranium, for example, radon is gaseous. So you can inhale it if you have too much radon surrounding your house. So a lot of folks will keep radon monitors in their houses in order to avoid that dangerous radiation. But again, most alpha particles really not an issue unless you're drinking uranium water. So our next kind of radiation is beta radiation. And to avoid beta particles, take a sheet of aluminum foil, stick it in front of yourself. They are not going to make it through that aluminum foil. If you don't have aluminum foil handy, just make sure you stay 10 feet away from whatever is emitting the radiation. So if you have something on a lab desk that is emitting beta radiation, make sure you are social distancing ×2. Our third kind of radiation, gamma radiation, has the lowest ionizing potential. So as a result, it's the least dangerous, Not that it isn't dangerous, but it's the least dangerous of our 3 radiations in that you have to ingest more of it to cause damage to your cells. However, it is also the hardest to avoid. So if you want to avoid gamma particles, you have a couple options. So first, you could hide behind a set of concrete walls. If you do that, those concrete walls should be 2 meters thick to avoid any gamma particles getting through. Another option would be to build your fortress out of lead. And in that case, you need a lot less lead, half a meter thick instead of 2 meters thick. Another option would be to just stay 4 to 5 meters underwater in a submarine the whole time. Gamma radiation cannot get you there. Now, again, gamma radiation is the hardest to avoid, but it is the least dangerous. Almost everybody is going to be exposed to some level of radiation in their lives. It is not something that you need to be afraid of unless you are actively seeking out nuclear test sites and other dangerous places. So I don't say this to scare you. I just want to make sure you guys are aware. This is how if you do find yourself doing nuclear physics, these are some basic safety precautions that you're going to want to take while you're doing experiments. The other thing that's really important to know about radiation is that the quantity of radiation matters a lot. So you are exposed, like I said earlier, you're exposed to radiation all the time in your day-to-day life. Radiation cannot be avoided because there are radioactive particles that exist naturally. For example, any food that is high in potassium has some level of the radioactive isotope of potassium in them. But you do not need to stop eating bananas or legumes or any other healthy foods that have potassium. In fact, potassium is an important nutrient that you need to make sure you're getting some of. The radioactive isotopes of potassium are a tiny proportion of the total amount of potassium in the banana. And so what will happen is you'll eat the banana and you'll actually excrete the radioactive potassium before it can do any damage at all to your body. Now, if you are to go, for example, to the nuclear core of Chernobyl, most of what's left there is gamma radiation, which, as you know, is the least dangerous. But if you go into the nuclear core of Chernobyl, you are going to be exposed to a lot of radiation. And that level of radiation is very, very dangerous for your body. So when we talk about radiation, we need to talk about radiation exposure or radiation dose. So we measure radiation in becquerels, BQ. The US likes to measure them in curies instead. Think of it like meters versus feet. The other thing that we'll talk about is the radiation dose. So the radiation is the amount that you're exposed. The radiation exposure is the amount of radiation that you are exposed to, so that is in your environment. The radiation dose is the amount absorbed by your body. And we're going to measure that in sieverts, which we shorten as SV. When we talk about radiation, we're going to be talking about the level of exposure that you have in regular flights or regular daily activities. So you take a transcontinental flight. So, for example, from DC to LA, you'll be exposed to about 0.035 millisieverts of radiation. Again, this is not a dangerous amount of radiation. Similarly, if you get a chest x-ray, you'll be exposed to about 0.1 millisieverts of radiation, and you'll get exposed to about 10 during a CT scan. And these are all considered very safe activities as long as you're not doing them on a daily basis. Now, if you are living somewhere with a background radiation greater than 20 millisieverts, that's when we say, okay, you need to move, because that's when getting exposed to 20 millisieverts of radiation on a daily basis is starting to become really dangerous for your health. Trust me, and just a side note, you would know if you were in a place that had that level of radiation. This is not one of those places. Once we get up to half a sievert, we start to see blood cell damage. And once we get to 1 full sievert of radiation exposure, that's when you start seeing acute radiation poisoning. So the things that killed, something like what killed Marie Curie. Or if we want to talk about another example would be the Radium Girls, if you've read that book. Finally, if we get between 4 and 10 sieverts of radiation, that's when we start seeing fatalities. So 50% of people exposed to 4 sieverts of radiation will die, and those exposed to anybody exposed to 10 sieverts of radiation it is going to die. We have a 100% fatality rate at that point. So you can see there's a really big difference between the amount of radiation that we're exposed to in our day-to-day lives. So for example, on a transcontinental flight, 0.0000035 sieverts. Whereas, if we're having real damage, if we have to start really worrying, that's 0.02 sieverts. So you can see we're at we're very different amounts of radiation. So the reason I bring this up is I want you guys to be aware that radiation exposure is not atypical, and it's only dangerous when you're getting really significant amounts of it. So again, if you're planning on becoming a civil engineer, living in a safe place, building bridges, radiation is not something you really have to worry about aside from having a radon detector in your basement. If, on the other hand, you're planning on becoming a nuclear engineer and living in, for example, Los Alamos, you might want to consider some additional precautions that you can take in your life. So again, radiation is dangerous if you don't take precautions, if you don't protect yourself. So with that, our takeaways. So again, radiation can be dangerous, but only if you're exposed to very high amounts of it. Second, you are always going to be exposed to some level of background radiation. And finally, if you're going to study nuclear physics, make sure you have appropriate safety mechanisms in place. Lab safety, is something you maybe don't think about as much when you're in our physics classroom because we're not doing a lot of labs that involve dangerous materials. But if you plan on continuing to study physics or engineering, you're going to have to really think about lab safety because you start seeing a lot more dangerous lab materials that you want to make sure you are protecting yourself from. So with that, I'm going to go ahead and leave you to finish up topic 5.2. Best of luck and happy solving.